Hello everyone. Now let's go on with our A-level Core Mathematics 1, Chapter 5. After completing this chapter, you should be able to fulfill the following 6 goals. 1. Understand the link between the equation of a line and its gradient and intercept. 2. Calculate the gradient of a line drawing a pair of points. 3. Find the equation of a line in either the form y equal to mx plus c or alternatively ax plus by equal to c. 4. Find the equation of a line passing through a pair of points. 5. Determine the point where a pair of straight lines intersect. 6. Know and use the rule concerning perpendicular gradients. Understanding this chapter will surely help you find the equation of a tangent and a normal to a curve in chapter 7, which we will later on going through it. Today we are just fixing on chapter 5, and now let's go from 5.1. 5.1, it tells us that we can express a straight line, the equation of a straight line, in two forms. One is, I will just write it down. One is y equal to mx plus c, and alternatively we have already got the idea that we can express it like ax plus by plus c equal to 0. We should notice that a, b, and c are integers. Okay, let's just see example 1. In example 1, it requires us to write down the gradient and intercept on the y-axis of these lines. In question A, we have got a perfect form of y equals to mx plus c. We can just have a comparison between these two. Okay, so now we can find that we listed these two equations in a group, and we find that m is equal to minus 3, where c is equal to 2. And so the intercept is, it has a coordinates of where x is equal to 0. Y is just the exact figure of c, that is 2. So the intercept, it is a point on the y-axis with coordinates 0, 2. And question B, we find that we cannot get the information of gradient and intercept directly through the general form ax plus by plus c is equal to 0. We cannot get it directly from this formula. And so we have to make a little change on it so that it becomes a similar form in question A. So you can see with a little steps, we get it through down to here, where y equals to 2x plus 5 over 2. Similarly, we can get the corresponding gradient and the intercept. It has been listed on this slide. In example 2, well, now we are required to write question A and question B into the general form. We need to do some rearranging works to make, for example, in question A, to make y, 4x, and 3, these three terms at the same side of these three terms at the same side of the equal sign. We just do some rearrange, and so they just become 4y, that is the same with the original form, minus y, that is because it has been moved from the left hand side of the sign of equal to the left hand side, so a minus sign is required in this case, and plus 3, that is the same. So we got it as the form of a general form here. Question B, that is in a similar way. The only difference is that the gradient is a fraction, and we just need to times 2. In this case, at here, times 2 on all terms of the equation, so that each number is a integer. Okay, let's come to question example 3. It is like this. A line is parallel to the line y equal to 1/2 x minus 5, and its intercept on the y-axis is 0, 1. Write down the equation of the line. What do we get when we are told that a pair of lines is parallel to each other? So under these circumstances, we can know at the first glance that they share a same gradient. It also in this textbook, it also reminds us, remember that parallel lines have the same gradient. So the only difference comes from the intercept. We know that the new intercept on the y-axis is 0, 1, where 1 is the point approach the y-axis. So we just got this one like that. 1/2 is the same as the gradient. We got the solution to this question. The next example. A line is parallel to the line 6x plus 3y minus 2 equal to 0, and it passes through the point, a fixed point, 0, 3. Work out the equation of the line. First of all, we can do a little rearrangement so that we can get a clear idea on the gradient. And since it passes the point 0, 3, where the x-axis is 0, x coordinates is 0, so it just means the intercept we already know from the contents of the question. So in this case, the intercept is 3, so we can get the conclusion, valid conclusion, that the equation of the line is y equal to minus 2 times x plus 3. The next example. A fixed line meets the x-axis at a point, and we need to work out. Well, when a straight line meets the x-axis, so what does it mean? We can get a short graph on this slide, on this page. So as you can see, if a point meets with the x-axis, at this point, the y-coordinate is 0. So we just make a substitution. We can get a valid answer to this question. Okay, let's come to 5.2. In this 5.2, we know that we can calculate the gradient. So it is a concept that when the x-coordinates has a change in amount, so what there's a corresponding change amount in y-axis. There's a rate in this type, so that the gradient is just the representative of this type of rate, where we can have the formula to illustrate this kind of by using the formula. In this case, we need to know 2 points on the same line. Let's just watch for example. Example 6. We have 2 points 2, 3, and 5, 7. Well, to this graph, it's up to you. You feel free to draw this kind of graph. Anyway, we are expected to include the formula into our calculation, and I will not refer to it into the class. It's not a difficult one, so you can just go through it after class. Example 7 is similar to the previous example. We just skip it. Okay, now let's come to example 8. In this case, 1 point for a, we don't know the value of a. We need to work it out. So we are expected to use the formula m equal to a fraction y2 minus y1 as a whole over x2 minus x1 as a whole. In this case, the term that is remain unknown is only a. So we can just use the formula to calculate the value of a, as these 3 lines shows. Okay, that's it. We can go to the next page. 5.3. You can find the equation of a line with gradient m that passes through the point with coordinates x1, y1 by using the formula y minus y1 equal to m times a bracket where x minus x1 as a whole. So basically we just work out the gradient and use this formula. We can just go through with this example 9. Find the equation of a line with a gradient 5 that passes through the point 3, 2. We got the gradient 5. Well, we can just use the formula. In this case, y is 2, y1 is 2, x1 is 3. So we can just write y minus 2 is equal to gradient, that is 5, has been shown illustrated clearly in the context of the example question. Is equal to 5 times a bracket where x minus 3 as a whole. Example 10. Find the equation of a line with a gradient minus 1/2, that is a value already known, that passes through the point, and this point is also known to us. So we can just include the formula with ease. And just remember, we are expected to write the final answer in a general form of the equation. Okay, let's come to example 11. The line y is equal to 3x minus 9. It meets with the x-axis at the point A. Find the equation of the line with a gradient 2/3 that passes through the point A. Write your answer in the another general form. A, B, C are integers. We know that it meets with the x-axis at the point A. As we have already talked about such kind of examples, when it meets the x-axis, so it means the y coordinate is 0. So we substitute the y with 0, and we got the x-axis. And once we have got this axis, the point, we can include what we have learned in this 5.3. We can include this formula. And the very last step is to rearrange the formula to be into the form exactly the same as the ax plus by plus c is equal to 0. Exactly this kind of form. Okay, let's come to 5.4. You can find the equation of the line that passes through the point with coordinates, 2 coordinates, by using the formula is listed here. We can first see example 12 to have an idea that how this formula is derived. Let's just have a look at example 12. Work out the gradient of the line that passes through these 2 points, and hence find the equation of the line. Since these 2 points are in the same line, so as long as we have already worked out the gradient, we can include 1 point to work out the equation of the straight line. We got 2 points and we can find the gradient. It is 4. we just include this point 5, 7, use the formula above in the previous page in 5.3, where y1 is 7, x1 is 5. We can know that the original formula is like this. Y minus y1 is equal to a gradient times x minus x1. Okay, we can substitute this m with y2. We can see from the graph, this is y1, this is y2. y2 minus y1 over x2 minus x1. That is a gradient. So we just replace it in this term. So we get the formula like this. Well, I'm sorry that this might be not clear. I will read it for you. Y minus y1 equal to a fraction times a bracket. Fraction is x2 minus x1. Or I can say y2 minus y1 over x2 minus x1 times the bracket x minus x1. And we can just do some arrangement and we will find it is exactly the same form as this formula. It is how it is derived. Okay, let's just see example 13. We got this formula and we are expected to find the equation of a line that passes through 2 points. So we just include it into our formula, use some substitution with the corresponding values, and we can just get this with ease. Okay, let's now come to example 14. The lines y equal to 4x minus 7 and 2x plus 3y minus 21 is equal to 0. These two lines, they intersect at a point A. The point B has coordinates minus 2 and 8. It is a known value. Find the equation of line that passes through these 2 points. The very first thing we need to do is know the coordinates of point A. We can do that just to make a little substitution by replacing y in the second straight line with 4x minus 7. So we got only the unknown term x in the whole equation and we can get a solution. And we just substitute the x into y and we got the y coordinate. So we got a, the full coordinate of a. Again, we got these 2 points, they are on the same line, and we can include the formula in this 5.4. Later on, working will not be a tough one. You can just do some arrangement, and if it wants you to list it like the form ax plus by plus c equal to 0, that is also not very difficult. Simply a movement, or if you like, just like what he said, subtract 9 from each side. So this time it becomes 0, and there is a corresponding value in the left hand side of the equal sign. Now let's come to 5.5. In this part, we can work out the gradient of a line that is perpendicular to the line y equal to mx plus c. So basically we have 2 points of concept under this title. One is that 2 lines that are perpendicular to each other, the product of the gradient is minus 1. Actually, these 2 points are referring to the same thing. If we have a gradient of m of one line and another line perpendicular to it, so it has a gradient of minus 1 over m. So you find that m times minus 1 over m, the product is exactly minus 1. So these two black points, they are referring the same thing. In example 15, we need to work out the gradient of line that is perpendicular to the line with these gradients. You know this point that the product of two perpendicular line is minus 1. So in question A, we have got a gradient of 3. So there must be a gradient of minus 1 over 3. And the other two examples are similar. Okay, show that the line, these two over here, they are perpendicular. The latter equation, we need to make some arrangement like it has been illustrated on this page to be in the same form as the previous this equation, so that we know both the gradient of these two equations, so we can get an idea whether they are perpendicular to each other. Now comes the example 17. We need to judge whether the pair of lines are parallel, perpendicular, or neither. Always remember that perpendicular refers to two straight lines with a same gradient, and parallel. Perpendicular, so it means two gradients, the product of two gradients is minus 1. If we can understand and master these two criteria, we will find it not very dreadful dealing with this question. For example, the question C, y is equal to 1 over 2 x times x, and the other one is like this. We have got one gradient that is 1/2, and the other one we can also rearrange into y equal to mx plus c, this form, to find the gradient, and we find that it is 2. They are not parallel because these two values, they are not equal. They are either not perpendicular because the product is 1, not minus 1. So they are not perpendicular, not parallel. Example 18. Find the equation of a line that passes through the point, a fixed point, 3 minus 1, and is perpendicular to line y, also a fixed equation. We got to know that the product of two perpendicular lines is minus 1. This idea has referred to in this part for several times, and hope you can all understand and master it, learned by heart. So we got a gradient 2, another gradient minus 1 over 2 is necessary. So we just include it and include the number. Include the coordinate of the point into the formula, and we can get the right answer to this question. Alright, that is the end of this chapter 5. We can have a summary of the key points. One is that we have two general forms. This is in 5.1. You can refer to this page after the class. Second is we can find out the gradient when we know the 2 points on the same line in the formula like this. And also, we know that if we times x2 minus x1 in both sides of the equation, this one changed to this one. We can also find the equation of a line that passes through 2 points by using the formula. We have already got a derivation process in the previous page. And the very last 2 points, if two lines have they are perpendicular to each other, then the product of their gradients is minus 1. These 2 points are referred to the same thing. Okay, that is the end of today's session. Thank you for listening. Goodbye, everyone.